In this video, I'm going to be talking about evolution of communication systems, how it went from physical interaction to fixed wired networks, and then to wireless large range broadcasting to finally our current era of seamless high-speed digital connectivity. And finally, I will tell you among all these what amazed me the most. First of all, let's talk about wired era. The telegraph was first digital step using timed on-off pulses. The message was sent using the message was converted into Morse code, and when the receiver side it was received as a Morse code, and we have to convert it back into the real message. So the it was a bit problematic because everybody didn't know Morse code, and there were several problems. So with that, people wanted to hear voices. That's why a telephone came in. So the thing happened in the telephone is it converts speech into continuous electrical waveforms. Like that, it can send voices through wires. When telephone came in, more people wanted to talk. We needed a massive structure to manage these connections. That's when PSTN came in. PSTN means Public Switch Telephone Network, and it gave us hierarchical circuit switch system that made voice services reliable and standard for everyone. So, however, copper wires couldn't go everywhere, which led us to next massive leap, which was air. So then let's talk about wireless leap. We moved from spark gap transmitters for telegraphy to AM/FM radio, and then after that, finally to television. So it required even higher bandwidth to broadcast videos, and because of that, this shifted our focus from wires to new challenges like signal propagation, spectrum management, likewise. So to make this wireless world truly global, we had to look towards the stars. Move on to next slide and talk about global infrastructure. The satellites bridge the gap between continents, providing long haul links for voice and data. But space is hard. Engineers had to deal with latency and orbital dynamics to keep us connected. So, while satellites handle long distances, we needed new ways to move massive amount of data locally, and that's when digital shift came in. The digital shift, packet shifting, and network. Let's talk about that. We moved from analog waves to discrete bits, which gave us better noise immunity. Instead of one rigid circuit, we began segmenting data into packets with headers, allowing many people to share same link efficiently. This packet-based foundation is exactly what allowed the internet and mobile revolution to explode. World quickly, 2G gave us SMS, 3G brought us mobile data, 4G gave us high speed streaming, and 5G is now connecting everything with ultra low latency. So, researchers are already looking at 6G and terahertz band for the next level of densification. As these massive towers connect cities, smaller technologies began connecting our personal devices. Then let's talk about personal connectivity. First of all, Bluetooth. So our personal space, we use Bluetooth, a low power radio designed for short range pairing and energy efficiency is Bluetooth. And GPS is at the same time different. It used to for the global positioning system. It is mean by global positioning system, and it used to used satellites to calculate our exact position. And this brings us to the modern world where humans aren't the only ones communicating, machines are too. But before we finish, I want to share that one detail that truly blew my mind. It is that GPS accuracy actually depends on Einstein theory of relativity, which means satellite clocks move so fast and sit in such weak gravity that they experience time differently than we do on Earth. So, without mathematical corrections for special and general relativity, your GPS position would be off by 10 of kilometers every single day. It's incredible how deep physics is hidden in our pockets. Finally, what I want to tell you is networks are converging, wireless, optical, and satellite systems are all working as one seamless web, and our job is to balance the physics of the world with needs of people. Thank you.